and so we want to keep it to like 5 minutes.
Right.
At the 5-minute mark, I'll make a noise of some kind. I haven't decided what, and you'll have like a minute to finish, but I'm sure you'll be fine. Yeah, looks like a really cool lineup. I'm really looking forward to it. This is Joseph Adams, who is going to talk about GISP, compiling Lisp to Go. Thank you.
Hello, as I said, I'm Joseph, and I'm going to tell you about GISP, a Lisp to Go compiler. And I'm not going to show you any slides, just some code examples and a little Ask generation REPL. So first of all, the way GISP works is it takes a given Lisp program, generates a abstract syntax tree via lexicon parsing, takes that abstract syntax tree and generates a Go abstract syntax tree, and then with the Ask printer prints out a hopefully valid Go program, and the printer and the asked data types for the asked data types are available in the Go standard library. Okay, so I'm going to show you 3 examples. We'll start with the most trivial one, which is just a hello world. So you can see we're defining a main function here, which just prints out hello world. Note we're using font.println. We've got full interoperability with pre-existing Go code, and the code it generates for this looks pretty reasonable. It's that, and since this example is quite trivial, we'll move on to the next one, which is the factorial example. It's a bit big, sorry. So here again we have main and factorial. That's defined recursively, and one thing to note here is we're doing a type assertion, that's this bit here, on the output of the factorial call, and then we're casting it to an int. I'll come to that in a second why we're doing it. Additionally, we're importing this second package, core, which is what I'll get to now as well. The code it generates looks like this, and you'll notice that factorial returns a core.any type, which is an empty interface, which means that in this case we're not type safe. I'm working towards adding optional type annotations, but that's what the type assertion and then the cast are for, so that we get the proper output with the printf. And another thing to note is we have this if condition, the if statement here, wrapped in a function literal call. We do this because in Lisp everything is an expression, as you probably know. But in Go, statements don't have values, which is why we wrap this in a function literal. So we get the value as the return of the function. Coming to the third and most complex example, this is the solution to the 14th Project Euler problems, if you're familiar with that, the longest collapse sequence. You'll notice we have loop and recur constructs which enable tail call optimizable functions or algorithms generally, which are usually not possible in Go. And we also have bindings with a let and in the loop. They support multiple return values, so you can also use those if you have libraries that do multiple return values, like most of the standard library. And let's jump to the generated code. So just to note, this is about 30 lines. The indentation on this generated Go code is quite extreme, not very idiomatic in general, and I'd like to change that. Another thing is you can see the operators like add and greater than, less than, greater than, equal, and so forth. They're all abstracted away as functions also in core, because the empty interface doesn't define addition, subtraction, and so on and so forth. Another thing to note is if you look at the function name here, it's, as usual in Go, camel case, but if we look back at the Lisp, it's, well, separated by dashes, so all the identifiers also in the bodies of the functions, they're made idiomatic, so that means it doesn't look odd if you're calling GISP code from your Go program. So to wrap up the talk, you've seen lots of the generated code, I'd like to show you a little example of the ast. I'd like to show you a quick example of the ast generated for the Go. So let's say we have some function call. We support integers, we also have floats, complex numbers, vectors, which are handled as slices, and so, which are handled as slices. And the ast that gets generated for that looks like this, and that just gets printed out, and that's what you saw before. And that's GISP. Thanks for listening.
Alright, that was awesome. There's no time for questions, so you'll have to query afterwards. Is Florin? Yep, cool. Florin Paterno is going to talk about Go with IntelliJ IDEA, and not just that, but it's a Go plugin for IntelliJ and IntelliJ-based IDEs.
I might need a second or so.
Actually, maybe if you want to answer any questions, Joseph, if you want to answer any questions just while he sets up. Does anyone have any questions for Joseph? I have one. Do you use it for serious things? Like genuinely?
Well, no, it only exists for the past few weeks. I've been working on it for the evenings after school, so nothing yet.
Cool. Well, thanks again. Yes. Oh, the schedule for this. I tweeted it from the Golang Twitter account. And I have it as like a screenshot on my phone. But I can tell you that next up is Powered Go with TyDot, which is a document database engine powered by Go. And then Gova Lewis is writing a database driver for fun. And then Quinn Slack will present on WebLoop using Seago to hook into WebKit. And finally, we'll be finishing with Remy Udofeng about why contributing to Go is cool. It is cool. All right.
So, yeah, I'm set up. Hello, my name is Florin. I'm about to present you the plugin for IntelliJ IDEA and other IDEA-based IDEs from JetBrains. About me, I'm a developer for about 10 years now. I've discovered Go 8 months ago, and since then I've written more Java than Go due to this plugin. I work at Protein, where we do a football app. In case you are into football or soccer, as Americans call it, check it out. It's pretty cool. But enough about that. For those of you who don't know about JetBrains and IntelliJ IDEA, they are specialized into creating IDEs. IDEA is specialized for Java and a bunch of other languages. From their website, you can see that they have a smart code completion, which is really smart. They can do on-the-fly code analysis for various problems in your code. They can do refactoring of your code, moving classes, and so on. So if you are into Java, give it a try, and not only. Like I said, they support Scala, Groovy, Clojure via plugins. They have a database client integrated for Postgres, MySQL, Oracle, just about anything. They have specialized IDEs for PHP, Python, Ruby, and they work as plugins for IntelliJ as well. And yeah, here the Go plugin comes in. About 1 year ago, the plugin was working-ish, let's say. But due to version upgrade, it broke. So that's when I started working on it. And since then, the basic features of the plugin that are currently sort of working most of the time are language parsing and highlighting, auto-completion, import variable, unused variable and parameters, and whatever detection. It has Go Get integration as well as Go FMP, Go Build, Go Run. It supports displaying documentation for various functions and so on. Yeah, let's give it a try actually. It's much better and I hope it will be quick. This is IDEA running. I'm launching it from my debug session, so that's why it looks a bit funny. Basically, when you start it, you have a list of your projects that you are working on, or you can create a new one. Creating a project is fairly simple. We just go here, selecting the application type, and yeah, that's about it. You just need to select your Go SDK. We support multiple SDK integration. Right now I have 1.1.2 and 1.2 on my list. And running quickly through the steps, you'll get into this Hello World application, which runs pretty well. Okay, I'm finding it a bit hard to find the mouse. Like I said, we support auto-completion for standard packages and as well as third-party packages. We support parameter descriptions, so you can easily view what happens there. When you are finished with your program, if you want to run it, you can run it. And yeah, hello world. Quickly, what else do we support? We support running something more complex, like the app engine applications directly from here. Better support will be added in the upcoming release, but for now, in the development release, oops, I did something bad. Yeah, basically it should launch the Go app engine, and you should be able to see the page and develop normally on it. Okay, and as the last feature that I want to show you is the debugger support feature. I'll be quick. Okay, so yeah, it's the feature that takes up most of my time right now. It's basically integrating GDB into IDEA, which is hard on its own. But yeah, as you can see, we already have support for some parts of it. You can step through the code and you can see changes in the code in real time. You can also see the output here. So yeah. Okay, and quickly back to the slide. There are some bad parts of it for the moment, but we are currently waiting for contributors to help, or you will have to wait for us to get around them. Go path support is not really that nice out of the box sometimes, so it could be improved. Custom installations could be a bit better, but yeah, sometimes maintainers have their own views about how to pack Go into various operating systems. We plan to add more code inspection, so for example, detecting automatically when you pass int64 into int32 function and so on, which I think we already do have. Refactoring improvements. Yeah, there's a Go IDE which will be maintained from version 1.0 of the plugin. Right now it's using an older version. I've already spoke about this. I didn't show you we support Go tests running directly from IDEA, which has a nice interface. So yeah, if you want to develop Go and you want to give it a try, please do it. We know it has bugs sometimes, but you are welcome to either report them or help us fixing them. Thank you.
Okay. Now, Howard. Great. So, welcome, Howard.
How is everyone today? Good? All right, so next, please allow me to introduce you to our document database engine implemented in pure Go. All right, does any of you speak Finnish? No? All right, to be honest, till this day, I don't, this is a Finnish word, but till this day, I don't know the Finnish pronunciation of it. But that doesn't matter. Let's call it tied-out for now. So what is tied-out? It's a NoSQL database engine. I began working on it about half a year ago. It is designed to be really easy to be embedded into your Go programs, and also it can run a standalone HTTP service if that's how you like it. It is cross-platform. It has been tested in Windows, BSD, and Linux. It is also very small, which makes it, kind of nice to use as an embedded database. Please search for the name on Google or GitHub to find the project. It's hosted on GitHub at the moment. So what are some of its features? To those of you who are familiar with document database engine, it's very much like CouchDB or Mongo, where you insert schema-free documents in JSON format and execute queries in JSON as well. And at the moment, it supports hash index to assist in lookup queries. In the future, we will support range query as well, hopefully, by introducing some other index structures. And a design highlight of it is that it really focuses on the throughput of I/O operations. So collections and indexes are all partitioned to allow parallel I/O operations executing in one collection, which makes it really different from Mongo from this perspective. Let's get a taste of the HTTP API. I was hoping to make it straightforward, so in the beginning, we create a collection called article, and we allow at most 4 parallel I/O operations by partitioning the collection into 4 parts. We insert a document into the collection with some HTML parameter right there. Name is golang and source is golang. And we place an index on the source field in the article collection, and we can query for articles which has source equal to golang.org. And if we want to delete a document, is also straightforward. Delete in article collection the document which has ID number 531. Also, the design emphasis also puts a lot of attention to the embedded usage. So I was hoping to make the embedded usage also simple as well. Open a database, create a database, and start using a collection. Insert something, and this has to be, at the moment, a map between string and interface, which is how JSON is serialized into Golang structure. But in the future, we will support, you can put in virtually any struct that you define, maybe a custom struct. Construct the query just like how we do it in HTTP. Evaluate the query to get result, and then do a for loop on the result to read the document back. I hope that's simple enough. So let's run some throughput benchmark. I put a lot of attention into optimizing the storage engine to make it really fast in terms of throughput. So most database engines have a benchmark harness, like Couch and Mongo, to benchmark the engine speed, just to catch any performance issues. So does tied-out. So let's run a benchmark. Simple document CRUD operation, effective on 2 indexes, and the document is 1 kilobyte in size, which is fairly common. And on an Intel laptop with 2.6 gigahertz CPU, T-Dot performs really well in terms of throughput, like many times faster than Mongo. I guess it's probably because the engine is very small and it doesn't have complicated features such as replica set or sharding and other stuff. And also, because it supports parallel I/O operations on different partitions in a collection, also makes it reasonably fast. We perform we perform similar tests on EC2 instance, and we get still T-dot wins pretty much. And scalability is sort of, well, it's not ideal. It does not scale linearly according to the number of CPUs you have in your system, but it's not that bad. So what's coming up next? I'm hoping to use some of distributed system ideas, or maybe Aries distributed centralized messaging, that sort of protocol, to maybe make it a distributed database so that it no longer runs on a single computer but runs in a cluster to further improve the performance. And we all love performance. Our goal is to achieve linear scalability. And may as well introduce some high availability features. So since its first release 6 months ago, about 600 people have started the project on GitHub. I appreciate all that, and I appreciate all the contributions. However, I pretty much wrote 90% of the code, so therefore I'm looking for more collaborations. Use whichever tool you like. If you like, you can. If you use Bizarre, we can set it up on Bizarre. If you use Camly Store, we will set up this repository in Camly Store. Thanks for your attention, and feel free to ask your questions. Go ahead.
Maybe I missed it. What does Hydrop mean?
Oh, it's
Data.
That was the finished word for data.
it's a finished word for data.
Anyone have any questions? You didn't already answer. No, thank you very much. Next we have someone with a very well-suited name to Go development. Govert. Where are you from? What is
Holland.
Oh,
So-
okay, all right. And he's going to talk about writing a database driver for fun and freedom.
Yeah. Thank you.
Yeah.
Originally, I sort of tuned this presentation to about 10 minutes, so I'm going to skip through parts of it maybe, or just talk really fast. If I talk too fast, please raise your hand so I'll slow down. Now I actually have to get it to recognize.
That's all right. I'll spare you the animal noise. It's a little long.
All right, thank you. Let's see. Aha. So, this is a side project of mine that I started working on quite soon after I discovered Go. I wrote my own database driver. So first, a little bit about me. At work, I'm a technical lead developer at Go & Co Solutions. It's a really small company. And it's basically a Microsoft job. So that means C#, Windows, and Microsoft SQL Server. You might think, what are you doing here? It's kind of like wearing a Britney Spears t-shirt to a metal festival. But still, figured I'd come by. But basically, we're pampered with fancy developer tools, like really nice IDEs and stuff like that. But at home, I'm a full-time Linux user. I feel strongly about open source. I really enjoy studying protocols, studying how stuff works at the low level. And I have a tendency to overuse bullet lists, as you will probably all notice. I've dabbled with Go, Angular, and lots of other stuff, but Go is my main language at the moment. So that's a bit of an odd marriage of techniques, mostly Microsoft on the professional side, mostly Linux on the personal side. I like writing Go. I would really like my colleagues to write Go as well. So a native driver for Go for SQL Server would go a very long way. So Microsoft's SQL tools are really good. My colleagues won't switch away from that. Go is really, really good, and I want to work with both. At first, I tried using Alex Brinkman's ODBC driver, which worked really well, and the guy is really good at support. If I had any problems, I could easily reach him. But it does have some dependencies, especially on Linux. You have to have Unix ODBC, FreeTDS. It's not a pure Go solution. It would have sufficed for all my needs, but instead I decided to write my own driver. Like I said, the current solutions have a bit of complexity, so I would like a pure Go solution. So I thought, how hard could it be? The real reason I really wanted to write it is not because of the complexity or anything, but because I just really wanted to see if I could do it and if I could contribute to Go. And like I said, I would love working at the lower level, the packet level and stuff. So, introducing Go TDS. For those of you who are not familiar with the Microsoft SQL Server logo, it looks like this. So that's where it fit really well. What's done at the moment is I can authenticate with the server, not encrypted yet, that's coming. I can do simple select statements on integers and varchar, so strings. I can do update, insert, and delete statements, parameterized. What's not done and what's coming soon is what you see here, transactions, support for nullable types, I haven't done that yet. And some more data types, you can actually work with floats and date times and stuff like that. Like I said, this is really a personal project. I haven't focused on performance yet. So once everything is implemented, once I have a fully functional driver, I'm actually going to look at performance and refactor a lot of stuff, which is quite bad at the moment, I suppose. At the moment, I do a lot of copying of stuff instead of working with pointers and stuff like that. I really didn't think it necessary to optimize prematurely. So that. That's done. I'm probably going to skip this, but what's worth thinking away is that the protocol is called TDS. That SQL Server uses it was originally started or developed in 1984, which is quite a while back. It's been extended and extended and extended. There are a few weird parts in it. Mostly it has retained its... it hasn't done the shit, basically, which is a nice thing. How did I actually manage to write this SQL driver? It's quite easy, actually, since Microsoft has published a full spec. So everything is documented really nicely, actually. And I could just read from that and type away. That was no problem at all. I didn't have to reverse engineer anything. It really saved me a lot of research. So what I did is that first I tried to log into the SQL Server from Go. And after that, I took a look at the database /SQL interfaces and see how I could implement those. It's actually not database /SQL, it's database /SQL/driver. There are a few interfaces there. If you implement them, if you satisfy them, you have a functional SQL driver. So I'm started implementing these one by one, and sometimes I looked at some other database drivers to see what I could borrow. It wasn't that much, but it was really useful to learn how other drivers do it, because there's a lot of solutions you probably haven't thought of, which you can use. So to prove I'm not full of shit, I'm going to try, if I still have internet connection, to actually run a query against the SQL Server. As you can see, it's just select 1, 2, 3, and try to print that out. And this is the part where it always goes wrong in live demos, I suppose. There we go. So it actually works. So what I learned is, I'm going to skip through this. Basically, writing a database driver means assemble a package for the SQL Server to process and learn to process its response, and wrapping that up in the existing interfaces. About writing a database driver in Go. Go is actually a really nice language to do this sort of stuff in. Working with slices really, really helps. It saves you a lot of headaches which you normally get from working with arrays. Everything feels very smooth, very thought out, except UTF-16, because Go naturally uses UTF-8 mostly. There's some UTF-16 support in packages and stuff, but I had to basically adapt that to my own package. But it wasn't much of a bother. It was really easy to do. Just keep it in mind if you need to work with different encodings. I didn't need to use concurrency at all, since the existing database SQL package actually handles that for you. It handles connection pooling, a lot of stuff. Database /SQL really simplifies a lot for you. You only have to do some basic stuff, and the rest is handled by that package, which is sort of a double-edged sword, because if you want to implement more advanced features of your database server, you can't actually do that, because the existing interfaces don't allow for it. For example, if you have Mars, which is multiple active result sets, that basically means you can fire off multiple requests through the same connection. You can't do that out of the box if you do it through database /SQL. SQL, I'm sorry. I'm Dutch. I learned to pronounce it SQL for some reason. Oh yeah, the biggest reason, biggest takeaway I actually learned is don't use a dash in your project name. It works fine for URLs. It doesn't work fine for the compiler. You can't name your package blah dash blah, which isn't really a bother for me since no one uses my package directly, but it will really screw you up if you do it. So don't. I've heard some people say don't use Go in your project name either. I had less of a problem with that in this case since it's basically a bridge between Go and TDS. So if you want to write a driver for something, just go do it. Read a lot of stuff. I read an immense amount of stuff before I even started writing a little bit of Go. Whet your appetite, and then when you're actually writing stuff, read all the stuff that make you enthusiastic about the language again, because often you forget stuff that is really awesome and you can actually use it. Yeah, like I said, Go is very thought out. I'm going to skip through that. I've kissed enough butt now. Some links, I've actually put it up on different sites, as you can see, which wasn't really necessary, but I do it because I like to. Raymond's ODBC driver I mentioned, you can download it from there. And if you want to look at any of the open specifications, there's a lot more on DNS, a lot of stuff. Look through it. It's like a whole bunch of PDF files. You can find it on that short link, which you have approximately 15 seconds to type, I think. So thank you very much. That was my presentation.
Now where's Quinn?
Right here?
All right.
Yeah.
Thank you. Okay.
Okay, cool.
All right. Please welcome Quinn Slack.
All right, my name is Quinn, and I'm at SourceGraph right now. You can check it out. It might be useful for some of you. But I want to talk today about a library I made that helps you script web browsers. It's called WebLoop, and it's kind of like Phantom.js. How many of you have heard of Phantom.js? Okay, so pretty much everybody. It's like Phantom.js, but for Go, so it's much better. So why would you want something like this anyway? Well, it's good for testing. If you have some complex app you want to test, if you want to scrape the web, that's useful. And then if you have some application where the user can have like a web view, but you want to interact with it in certain ways, then you're going to need to script that web view. So that's where this comes in handy. So here's how Phantom.js describes itself, and here's the simple canonical example. You open a page, then you get a callback, and then you can run some code. And here they just exit. That seems like a boring thing to do. So I'll show you some other things that we can do. And then, you know, Phantom.js already exists, so why rewrite this in Go? Well, there are a lot of reasons, but they mainly boil down to I just like Go a lot better. And I can come up with bullet points, but really the bottom one is just code word for I love Go. So here's WebLoop. It builds on these 3 other libraries, and I will do a demo of it right now. So you have a web page. You just want to run some JavaScript in the context of that web page. So I made a little script. Oh, let me hook that up. Okay, so I made that little one-line script, and then you can run it with this little command. You say the URL is the first argument. That's the context it runs in. And then the script file. So you run it, and it's a little bit slow because it has to like load up GTK and load up WebKit and all of that. But behind the scenes, it does all that, and it loads it up in some WebKit view, executes that script, and then gives you the response just as a JSON encoded value. So there's a lot of stuff going on right there, but that's the simple output. And you can make that a lot more complex and get a lot more other information out of the page. So the next demo I'll do is, this is a little bit more complex. So if you have like an Angular app or some other single page app that is a total, rich JavaScript app, the problem is if your users don't have JavaScript enabled, or if there's a search crawler, they're not going to see anything. They're not going to see any of your content, and that sucks. So how can you show them a pre-generated static HTML page with the content so that even if they can't use the app, they can get some of the data? So I'll show you how this is done. So let me resize this. So here is a simple app. It's like a list of cities, and this is Chrome, which has JavaScript enabled right now. It's running Angular, and I can click around and shows you, the information. So that's great. That's an Angular app. But now I'm in a browser where we don't have JavaScript enabled, or I could be like the Google bot. So all I see is this. There's nothing there, so that sucks. So I have on another port, basically WebLoop provides an HTTP handler that says, go and hit this other server and emulate being a browser, look at what the HTML is after the Angular app is run, and then take that statically generated HTML and present it back to the original request as the response. So it's just an HTTP handler that you can stick into your own web applications, and it'll go and do all that work behind the scenes for you and present your users who don't have JavaScript or a Googlebot with this nice statically rendered page. And this is statically rendered. You can see if I click on a different page, the whole page changes. It's not where only part of the page changes in Angular. And you could throw this up in front of your web page, and then Googlebot and your non-JS users would be happy. All right. So I want to integrate this with some other Go web frameworks like Martini and some of the other ones that people use. And if you're interested in contributing an implementation of a handler or middleware, then I would love to get that. And then also do asynchronous messaging so that you can wait for a page to have a certain condition and then run some JavaScript in there. Right now you have to poll. And that's actually possible with WebKit too. So Seago Experiences is a library author. It's been really good overall. There's nothing that I would change, but some things to be aware of. People are not expecting like package config to run when they run go get. And probably half the issues that I've gotten on this repository has been like, I don't have this dependency. And the other thing is builds are slower. So maybe if you could use a shared C library, that would speed things up during compilation. It's not a big deal, but GTK and WebKit are pretty big. So it takes like 5 seconds on a nice machine. Is that the end?
Let's wrap it up.
Okay, that's it. So I'll take any questions. You can go and look at the code. I was going to show what it looked like, but you all have computers.
Which JavaScript engine does it use? Other Java process?
It uses whatever WebKit 2 has.
You know what that is?
I assume it's V8. What's that? Yeah. Mm-hmm.
Can you use it to display a dynamic website in links, for example?
Yeah, you could. Yeah, I mean, if you open up this thing that I had in Firefox in links, it would show you the HTML. Yeah, you could use it as like an end user, just to proxy the entire web. Any other questions? All right.
Thank you very much. And now we have our final lightning talk, unless somebody spontaneously decides to do one. So we do have space for one more, if there is one more person. But if not, I welcome Remy Udumfeng, who is, do you have any slides? Or you just,
No.
who's actually one of the committers on the Go project, has done a whole lot of amazing compiler work. And so he's going to tell us why contributing to Go is cool.
Okay, so I am Rémi Udumfeng. I work in Paris for a large French bank, and we are using Go professionally, essentially, since 2011. And well, for the moment I use it essentially professionally and not really for personal projects, because I do some other things at home. And at first we wanted to use essentially for systems programming, and progressively we explored usage as a general programming language. And we didn't initially expect to contribute significantly to Go. So actually, the Go repository is a lot of fun things. It's a lot of interesting code. For example, the standard libraries of exceptional quality, varying depending on the libraries. But for example, it is somewhere where you can find a readable HTTP implementation, you can find readable cryptographic code, or you can find readable, well, a lot of things. And it is also fun to have a compiler which is only a few thousand lines of code, because I absolutely never saw a GCC or LLVM code, so it was the first time I could read and even write a bit of compiler code. So what did we do? The first thing the first significant contribution we had to do was an improvement to the strconv library, because we wanted to be able to parse numbers efficiently, because we had a lot of numbers to read, and of course, since people don't do things very efficiently, we had a lot of numbers to read in plain text. So this is extremely slow, and the initial implementation available in the Go standard library was not very fast at all. So we wanted to port in plain Go the algorithm which is used in the double conversion library, which is, for example, used in V8 or something. And I think it took me a few weeks and months to totally implement the algorithms found in that library. And I think the result written in Go is more readable than the initial one, which used templates and every possible C++ feature just to parse a string into a number. And well, after that, I had a lot of random things, something like bug fixes essentially in the compiler, in at some point in GCC Go also, or in the race detector. And usually these were almost always motivated by real needs, not always, because sometimes there are some fun things to do or some fun bugs to fix. And for example, the strconv case was motivated by performance, but we also had to implement freeing of memory to return to the operating system, because initially you could have a Go program, let it run for a while, it would allocate some memory and then never return it, although the garbage collector has worked. So a bit of Haddock scavenger thing was implemented in the runtime, and it was contributed upstream 2 years ago. Also, the work on the race detector was to have it working a bit earlier, because it was an amazing piece of software, and I couldn't run it on my code because of some compiler issue. So it was very interesting trying to dig into the compiler, sometimes a bit annoying, to have it work properly on all of our code. And also, contributing to Go has many advantages, like having your code reviewed by amazing people, because I think it's not very often that you can have code reviewed by Russ Cox or by Rob Pike. It gives you free distributed testings on the user, because sometimes you can have some improvement to a standard library on your local repository, but, well, it might be useful, but you don't have really time to test it completely. So if it's good enough to be accepted in the main repository, you have it tested by thousands of people, and that's pretty cool. And also, I think an interesting thing is trying to indirectly improve projects we like. For example, I think Brad makes me want to try Camlistore, and if my contributions can help Camlistore work better, I'm pretty happy to see that happen. And finally, I think there is a lot of work to do. The compiler is still easy to crash. For example, there are a few annoying bugs that are still open, and I think some of them are really, really hard to fix. Also, there are some bugs I encounter, and I would like somebody to fix them. For example, it's been 6 months since we are annoyed by a bug in the GNU C library, which makes DNS requests go on random file descriptors. We were hit by that in June, and actually It happened that somebody else also encountered the bugs, and well, it's just a race condition. If you use the default Go standard library, it will use CGO to resolve host names, so all requests will go to the C library. And if you in parallel have open sockets, and if you do also name resolutions, you will see random packets happen on your file descriptors, which is quite annoying. And I think nobody tried to fix it in the C library, or maybe many people tried but nobody succeeded. So I hope that someday someone will fix it. And I tried reading the C library code, and it's really horrible. And well, there are also very large transformations will come in the next weeks, and Andrew has already said something. So I hope there will be still a lot of exciting things to do.
How many hundred changes do you have in the standard library at this point?
I didn't count, but that's not so many.
Yeah.
It's a lot.
Yeah, there may not be that many, but they're pretty good changes. That's cool. All right. Well, that's it. Thank you to everybody who's been hanging out in here all day, or if you've just been here for the last little while. It's been a lot of fun. Send mail to the FOSDEM organizers and tell them that we need a bigger room next year. Because I think we probably do. I think we could go for a bigger room. And yeah, of course, if any of you have things you want to talk about next year, please follow the Golang Twitter account, and I'll let you know when we're taking proposals or whatever. I should mention Francesca's speaking in Brussels tomorrow. He's also a member of the Go team.
Yeah, it's going to be at 6 p.m. at the Google office in Brussels.
So if you're in Brussels tomorrow, it's worth coming along.
I think it's going to be beer, probably.
There'll be beer there. So in case you haven't had enough beer this weekend. And if you're from Berlin or going back there, I will be speaking in Berlin on Tuesday night. I don't know if there are any spaces left at the event, but there may be. And also, Francesca speaking in Paris on Wednesday.
Yeah, Wednesday at Google office, but in Paris. So, that was it.
So if you haven't had enough, go. There's more.
Will there be wine there?
Actually, we have a very good room with champagne and very fancy.
Oh, that's cool. I wish I was going there. Also, there is a Go conference, the first kind of large-scale dedicated Go conference in Denver, Colorado, in the United States in April, called GopherCon. And the lineup looks pretty awesome. Everyone except me looks great. Yeah, it should be really fantastic. Also, recently quietly announced is the .go conference, which will be a one-day Go event organized by the .cloud people in Paris in October. And I think at least a few of us here will be there. So keep an eye on that too. Let's go and drink.